Okay, today we're going to solve our systems of equations using a method called substitution. So we'll start with our steps again. Given our two equations, we're going to take one of our equations and solve for a variable. So we need to get that variable by itself. Our second step will be to take what we get from step one and plug it into our other equation that we haven't used yet. And when we plug that in, we're going to have to use parentheses. Our third step is going to be solving the equation that we just substituted into, so from step 2. And then our fourth step, we're going to take the answer from step 3. Oops, sorry. And we're going to plug it back into our equation from step 1. That will give us our solution that we write as x comma y. So keep these steps in mind. We'll go through this example together, which will help. So here's our system of equations. 4x plus 3y equals 2 and 2x plus y equals 6. And our goal is to get that xy coordinate point that is our solution. So yesterday we talked about graphing, solving by graphing. And we got that where those lines intersect is our solution. Well, this is just another way to solve. So instead of graphing, we're going to use a substitution method. So step 1 said to take one of my equations and solve for a variable. At this point, you have 4 different routes you can take, but I always try to look for the easiest route. So our easiest route in this case would be to solve the second equation for y, because there's no coefficient in front. Okay, so I take 2x plus y equals 6, and I'm going to solve for y. So I subtract 2x, giving me y equals negative 2x plus 6. Now, we take the equation that we haven't used yet, so 4x plus 3y equals 2. And since we just solved for y, I'm going to take negative 2x plus 6 and substitute or plug it in for the y in this equation. This is where we use our parentheses. So I substitute y, and it looks like this. So now I have 4x plus 3 parentheses negative 2x plus 6 equals 2. Okay. Here, I'm going to distribute. So I get a negative 6x and a plus 18. Then I'm going to combine my like terms. So 4x minus 6x gives me a negative 2x. Now I want to get x alone, so I subtract 18. That gives me a negative 16. So I divide by negative 2, which gives me x equals positive 8. So we are now done with step 3. Step 4 says to take this solution, and we're going to plug it back into our equation from step 1. So we're taking x equals 8, and we're going to plug it back into this equation. So I do that over here. I take y equals negative 2x plus 6. We just solved for x and said that x was negative 8. Was positive 8. So now I take negative 2 times 8, which is a negative 16. Plus 6 gives me negative 10. So my final answer, which is step 5, is positive 8 comma negative 10. So again, if you go back to your foldable from the other day, you're going to the second page, which is substitution. So here we have our system of equations. And it's really nice in this example because our top equation is already solved for a variable. So we don't need to do any solving. We're just going to take this 2x plus 5 and plug it into our second equation. So we get 3x plus, remember use your parentheses, 2x plus 5 equals 10. There's no distribution, so we just combine like terms. So 3x plus 2x is where I get the 5x plus 5. We want to subtract 5 to the right side. 10 minus 5 would give us 5, so we have 5x equals 5. When you divide by 5, you get x equals 1. Again, we're on to step 4, where we're going to take x equals 1 and plug it back into this original equation. So we have y equals 2 times our x value. X was 1. And then we add 5, so we get y equals 7. So our final answer as a coordinate point is 1, 7. Okay, here in this system of equations, neither variable are solved for, neither variable are solved. So we need to take either equation and solve for any particular variable. So in this example, I chose to take the top equation and solve for x because I just need to add y to the right side. So when you add y to both sides, you get x equals y plus 3. Okay, now I'm going to take this y plus 3 and plug it into the other equation that I haven't done anything with. So I did that here. Y plus 3 plus 2y equals 6. Combine your like terms, you get 3y plus 3 equals 6. Subtract 3, 3y equals 3. We get y equals 1. Again, take y equals 1 and plug it back into one of your original equations. So I went ahead and plugged it in right here. However, you could plug it in here as well. You get x equals 4, so your final answer is 4, 1.